Welcome back to our AWS AI Practitioner series. In the previous video, we learned the difference between the artificial intelligence, machine learning, deep learning, and generative AI. But have you ever wondered what actually happens behind the scenes when you ask the ChatGPT a question? How does Netflix recommend movies that you enjoy? How does Amazon suggest products that you seems perfectly relevant? So, Ira, how does Alexa understand your voice and responded instantly? So, all this, the answer is artificial intelligence. So, but AI isn't magic. Behind every AI system is complex workflow that starts with the collecting the data, ends with the delivering intelligent predictions to the users, right? So that's where the important how it is getting collected the data, how it is predicting the results, and how the predictions are getting delivered to the end users, right? Today today's video we will walk through the entire AI life cycle, so from the data collections all the way to the deployment and the continuous improvements. So by the end of this video, you will understand how modern AI system works in the real world, right? So let's get started. First, AI lifecycle. So every AI systems follows the similar journey: data collections, data preparations, and feature engineerings, model training, model evaluation, deployments, inference, and then monitoring and improvements. So these are the key steps for every model, right? Think of AI like the training a new employee. First day they will learn, right? So they will learn from the examples. After that they will start working it, and then over the time they continuous learning from the experience, right? This follows the same structure for the AI as well. Let's break it down by step, right? First, the data collection. So, what is the first step? The first step is the data collection. Everything begins with the data collections. So, the data is often called the fuel of AI. Without the data, AI cannot learn patterns or predict. It makes the predictions. Depending on the problems, the data can come many different sources, right? So the data may come from the text documents. The data is coming from may come from the images. The data may come from the audio files or video files or customer transactions or websites or IoT sensors or any. So there are many multi sources. So we are getting the data. So the first step is we have to collect the data. So the data can be in many sources, right? So in the real world examples, to build a spam detection system, we need thousands of emails. Or to build face recognition systems, we need millions of images. To build ChatGPT, the enormous amount of text from the books, and it will read articles and websites and other public resources, right? To collect all the data. One important rule in the AI is garbage in, garbage out. Look at this one. So if the data is poor quality, the data AI model will also perform poor. That's very important. How much data you are collecting and how much you are learning from the data, that is where the model can be accuracy, right? So the poor data quality, the poor model performance. Okay, so the better leads to the better AI. So now, so you might be understanding about the data, the importance for the data collections, how different kinds of data, how different ways we can collect the data. So based on all the historical data, so the model performance can be depends, right? So now the next step, so the data preparation. So we have all collected all the data, the raw data, but we have to make it in a proper organized way. So the data preparation, so that is very important now. So the raw data is ready, but what we may miss, or what raw data may contains missing values, right? Some raw data may miss the values or duplicate records or incorrect information or inconsistent formats. So before training begins, we need to clean the organized, we need to clean the data and organize this data. Example, suppose a customer database stores, let's take with the mail with the capital letter, mail with all the small letters, or mail with the all the capital letters, or M. So usually if you look at this different websites, different web sources, so somewhere it mentions the mail with the capital letter which stands for the male, or mail with the M, the letter M, which is also stands for the M, or F, which is stands for the female, right? But there is no accuracy, that different forms. As we human, we can understand the different formats, but the machine, in terms of the machine AI, so it's a different values, right? So now, we have to standardize this format into the single format. So this process is called the cleaning or data preparation, right? Data cleaning or data preparation. So now, interestingly, data preparation often consumed 60 to 80 percentage of efforts in the real world, real AI projects. So that's where the data, so important for the data preparation. So because we have to organize this data, so huge amount of data, not even we think about that, the billions trillions of data has to be organized. So how much you organize the data, so the predictions can happen very, so in a right way, so the results very accuracy. Okay, now next step comes to the feature engineering. So first the data, so data collection, data preparation. Now step to the uh, third step, which is a feature engineering. After cleaning the data, we identify which pieces of information is important. That is where, for example, so house price predictions, right? The potential features might include like, so if you want to predict a house price, we should know the house size, so number of bedrooms, locations, age of property. These are all the factors which can depends on to identify the predict the house price, right? So these are all the features help the AI discover patterns that influence house prices. The better of the features, the better the model can learn, right? So feature engineering is often considered both science and an art, right? So now the next one, so the model training. So now comes to the model uh, learning phase. This is a learning phase, how we train the model. So this is where the machine learning actually happens. The model is shows thousands or millions of examples. So example, for example, house size. What is the house size? 2000 square foots. Or bedrooms, number of bedrooms are 3, or prices 300 thousands. The model studied this example repeatedly and start identifying the patterns. See, same patterns, if you repeatedly learn if you feed to the model, then it will learn from the patterns. Over the time, it learns relationship between the inputs and the outputs. So this process is called the training. So the goal of the training is simple: reduce errors and improve predictions. The more quality data the model says, the better it usually becomes, right? So now comes to the model evaluation step, that is a step number 5. So now once the training is complete, we need to test how well the model is performance, right? Perform. So this process is called the evaluation. We use the data that the model has never seen before. So now this helps us determining whether the model truly learned the patterns or simply memorized the training data. Okay, the different types of problems use different evaluation a matrix, because during the evaluation matrix, how you can evaluate the model based on the matrix, right? We should have some metrics to identify whether it is a wrong or right, how much data is given, I mean, the right data has been produced, or how wrong the data, now how much the wrong data has been produced. So we have to evaluate the model based on some matrix. So that is there are two kind of different matrix: classification matrix and the regression matrix, right? Again, the classification matrix is divided like the problems such as like spam detections or fraud detections or disease predictions or cyber security threat detections. So this is a common evaluation. So these are the problems classification, right? So how you are classifying the spam detections or fraud detection. This is a classification. Just it's a spam or not. It's a classification, two ways, or is it fraud or not. So yes or no. Either you are yes or no. We are classifying the data. That is, but the metrics to classification metrics, with comes to the classification metrics, we have four classification metrics: accuracy, precision, recall, and F1 score. Let's understand these using the simple examples. So precision comes to the precision. Suppose a hospital uses AI to detect whether patients have a disease or not. There are 100 patients, and out of 100 patients, the 20 patients actually deceased. Let's say 80 patients do not, right? So now this is the actual number. So now AI model prediction, AI model can predict, and we can compare the reality. The prediction is called the prediction is the one. So whether it is the reality or not, the real number, or whether it is a near to the real number or beyond to the real number. So the prediction can happen. Now from the predictions, so now the what is the accuracy? So now from the prediction, the accuracy comes up. Accuracy tells us how many predictions are correct overall. So that's accuracy. So for example, the same example, if you take that, if AI correctly predicts 90 out of 100 patients, that means accuracy is 90 percentage. This means the model correctness is the 90 percentage of times, right? So real life example, if a student scores 90 out of 100, that means his accuracy is 90 percentage. The limitation is, imagine only one patient out of 100 actually has the diseases, right? If the model predicts everyone has healthy, accuracy is 99 percentage, but it completely missed the actual patient. So that's why the accuracy alone not enough always, right? Now come to the precision. So when the model predict positive, how often is it correct? When the model predicts positive, how often it is correct? That is a precision. Example, AI predicts 10 patients have the disease. Only 8 actually do. Example. So AI detects 10 patients as a deceased patients, and actually the 8 patients are deceased. Let's take 8 by 10, that is 80 percentage. Real life example. Think about the spam detection, right? When the Gmail marks as an email as a spam, we want to be truly spam. Okay, we don't want important emails ending up with the spam folder, right? So high precision meaning fewer false alarms. Easy to remember. Precision meaning, can I trust positive predictions? That's where is the precision, right? So recall is meaning, out of all actual positive cases, how many did the model find? That is a recall. There are actually 20 patients with the diseases. For example, AI detects 18 patients as a disease patients. Then recall is 18 by 20, that is a 90 percentage. So the real life, how we can consider, right? Consider cancer detection, right? So missing a patient who actually has the cancer could be a very dangerous. So in healthcare, recall is often more important than precision, right? So how we can remember, how many real positive did I catch? That's where the recall. Now comes to the F1 score. Sometimes we need both, right? High precision, high recall. F1 score balances both metrics into the single number. Real life, for example, fraud detection, if a precision is low, many legitimate transactions get blocked, right? If a recall is low, many fraud cases are missed. So F1 score helps to find out right balance. So what is F1 score? Balance between precision and the recall. To summarize these classifications, how the quick classifications: accuracy meaning how often I correct the oral. Precision meaning when I predict positive, how often am I right. The recall meaning out of all the actual positive, how many did I find. F1 score meaning how well do how well do precision and recall work together. So this quick summary about the classification. Now comes to the regression metrics. So for predicting the problems such as house price prediction or forecasting or temperature predictions, we use regression metrics. The most common regression metrics are MAE, meaning mean absolute error, MSE, meaning mean squared error, and RMSE, root mean squared error. Let's comes to the what is the mean absolute error, MAE. MAE measures the average difference between the predicted values and actual values. So in simple terms, on average, how far are my predictions. So for example, so let's take the example, there is a house price prediction of the house price. There is 300,000 for the house price. The actual house price is 300,000, but my model got predicted with the 290,000, right, or 290,000. Error is 10,000. Suppose multiple predictions with the multiple the errors like 10,000, 20,000, and 10,000. The average is 13,333. So the my MAE is 13,333. So the real life, imagine a food delivery app. If a delivery estimates is a 5 to 10 minutes, the MAE tells us the average mistake. So that's where easy to remember. MAE meaning average error. The next one is a mean squared error. Mean squared error average up squared prediction error. So why squared then? So because we want large mistakes to penalized much more heavily. Meaning, so for example, there is errors which is difference is 10, 20, 50. So there is a three error differences. Then if you square them, 10 become 100 and the 20 become 400 and the 50 become 2500. Average is 1000. The MSE is 1000. So it's a huge. So considering a self-drive car, predicting an obstacle at 3 feet instead of the 4 feet, it doesn't get serious. It doesn't get much difference. May not be the serious. The predicting 3 feet distance as a 30 feet difference, it might be the dangerous sometimes, right? So MSE heavily penalize such as a large mistakes. Okay, so easy way to remember: punish big mistakes, right? So now root mean square error, that is a RMSE. So it's simply the square root of MSE. So it keeps the benefits of penalized large while covering the result back to the original unit. Example: if MSE 100, then RMSE is 10. That makes the results easier to understand. So the real life example: suppose a weather forecasting model has a RMSE is 2 degrees of Fahrenheit. That means predictions are typically off by around 2 degrees. Easy to understand both engineering and the business users. So easy way to remember: average error with extra focus on big mistakes, right? Quick regression summary. MAE meaning average prediction error. MSE meaning penalized large mistake. The RMSE meaning most common used regression metric. Okay, now comes to the step 6, which is the deployment phase. Once the model is performs well, it's ready for the production. This process is called deployment. Example: ChatGPT, Alexa, Netflix recommendations, or fraud detection systems, or medical diagnosis tools. Deployment makes our AIs available to the real users. That's what we call the deployment phase. Now, after the deployment phase, the step 7. So that is inference. What is the inference? Training is complete, right? So training is once the training is complete, deployment is complete. Now the AI starts doing the actual job. When user provides new input, the model generates the predictions, right? So this process is called the inference. When the model getting predicted, that process is called the inference. Example: if you ask some questions to ChatGPT can give the answers. Or if you ask ChatGPT to generate the images, the ChatGPT can generate the images. That is the inference. That is called the inference, right? So if you upload the image to the ChatGPT can recognize the objects, identify the objects, and it will give the results. That is the inference, right? So if you receive the bank transactions and then the AI model can detect the fraudulent transactions or suspicious transactions, that is called the inference. The inference is where AI creates business values. That is where. So actual work, which is called the inference. Inference is make the business value, right? So the next step is after the inference. So the step number 8 is the monitoring and continuous improvements. Yeah, everyone think about that. Okay, after the deployment, the AI is done. The AI, the workflow is done, but that is not because in reality deployment just the beginning, right? Over time customer behavior changes, our business requirements evolve, our new data appears. So as a result model performance can decline. This phenomenon is called the model drift. What is a model drift? Over the time when the model performance is getting reduced or declined, that is called the model drift, right? To maintain the performance and to maintain the model performance, what organizations has to do continuously: monitor model accuracy, right, and collect new data and retrain the model, right, deploy updated versions. So this is creates a continuous AI improvements life cycles. So when you continuously monitor the model accuracy and collect the new data and retrain the data and deploy the new version, that is how we can keep the model with the latest, the continuously with the accuracy, the high accuracy, right? So we can continuously model with the improved versions. So now let's take the chat gpt example, right? So we can connect all together. So we learn all the steps. So these are the 8 steps. So from starting step 1 to step 8, these are the life cycle, right? So what we learn about the step 1, data collection, and the step 2, data preparation, and the step 3, which is feature engineering, and the step 4, which is model training, and the step 5, which is the model evaluation, and the step the in the steps 7, model. So the next step, and then the next step is the inference, and then the monitoring and continuous improvements. Okay, so now we can correlate with the chat gpt example. So now, so let's collect everything together. Collect massive amount of text, that is a collection of data collections, and clean and prepare the data, that is a data preparation, and train a large language model, llm model. Okay, and that is a training and evaluation of the performance, that is a evaluation step, and the deployment the model, that is a deployment step, and user ask the questions, the questions and answers, actually that is a inference, the model generate the responses, right? So now engineering team can continuously monitor the model, the performance, and they can release the features, right? That is the overall life cycle of the life cycles, right? So now key takeaways: data is the fuel of AI. Data quality impacts model quality. Feature help model learn patterns. Training teaches the model. Measures performance. Evaluation measures the performance. Accuracy, precision, recall, and F1 score evaluates the evaluation. Um, Classification models, right? MAE and MSE and RMSE evaluate prediction models, right? Deployment makes AI available to the users, and inference generates predictions, and monitoring keeps model accuracy over time, right? So today we learn how AI works end to end, from collecting data to the training models, evaluating performance, deploying the solutions, generating the predictions, and continuously improving them. Whether it is a ChatGPT or Amazon or Netflix, Alexa, or fraud detection systems, every AI application follows the same life cycle. So, in the next episode, we will dive into the machine learning fundamentals and explore how machine actually learn from the data. If you found this video is helpful, please like, share, and subscribe to continue your AWS AI practitioner journey. Thank you for watching, and I will see you in the next video.